All right, so section 6, we're going to talk applications today. Our goal is going to be to analyze a paragraph and create the equations. We did this back in Algebra 1. You guys actually did a nice job of it in Algebra 1, so I'm not too worried. But what we have here, let's just kind of talk through this. Remember, our goal is if we have 2 equations, then we need 2 variables. If we have 3 variables, we need 3 equations. So your first step you're going to have to do is kind of create variables. Try to choose variables that make sense, but also variables that are not confusing. Stay away from S, stay away from Z, stay away from T, all the variables that could be construed as a number. So here you have a situation. You have a youth group that's going on this trip skiing. How many people are going skiing? Read through it quickly. How many people are going skiing? Kylie.
64.
Read again.
76.
76 people are going skiing total. So I want to highlight that piece. This is a case where we have to really be careful. Don't feel bad. I was making the answer key. I did the whole problem using the number 64. And then I read the bottom and I was like, oh my. I need to read carefully and then write my equations.
Where does it come from?
Well, there's 64 members of the youth group and there's 12 chaperones. Do you see those 2 pieces of information? So we've got these 64 members. Whoops, sorry. These 64 members here, and we have 12 chaperones. So I need some variables. I'm going to say very simply, let's see, the vans can seat 7 people, the cars can seat 5 people. So I'm just going to say, hey, let V equal the number of vans. We're not talking shoes either. And C equals the number of cars. So every chaperone is going to be driving. And the question is, how do we go about this if we have vans and cars to go? Okay, so how many chaperones do we have? 12. What kind of equation can we make with regards to 12? Remember, what does V represent? The number of vans. What does C represent? The number of cars. Okay, so let's just make an equation. V plus C equals 12. That's it. Now, second equation. Second equation is a little fun, I think. It has to do with 76. Can you think of what relates to 76? 76 is the number of what? People. How many people fit in one van?
5 people. 7.
I heard 5, I heard 7. Which one?
Oh, 7 cars.
So, 7 people fit in a van. How many people fit in a car? 5 people fit in a car. I have 2 variables. I have 2 equations. I can now start the problem. We're going to do this problem with 2 different quick methods. We're going to do it with elimination and we're going to do it with substitution just to show you the different ways to attack it. How do you want to attack it first? Substitution or elimination? Elimination. Okay. So I'm just going to do a little squiggly here. And with elimination, I'm going to multiply this first equation by -5. What do you think is my goal here? Yeah, we're going to drop out the C's. And 12 times -5 is -60. The second equation stays the same. 7V plus 5C equals 76. So 2V equals 16. I get vans equals 8. Do you agree? How can you very quickly then tell me, hey, what does C equal? Marissa?
You plug it back into the first equation and say 8 plus C equals 12 and then subtract 8 from 12.
Okay, so we're going to plug it right back into here, this first equation. And so 12 minus 8 is 4. Pretty straightforward? Let's look at this from a substitution standpoint. I'm going to take this equation now, and I'm going to say, hey, you know what? V equals 12 minus C. because sometimes substitution is an easier method. Let's just see if it is in this case. So I have 7v, so 7 times 12 minus c, plus 5c equals 76. So 84 minus 7c plus 5c equals 76. So that's negative 2c, you see. So I'm going to bring over the 76. I'm going to move over the 2c. 84 minus 76 is 8, and that's enough. So I divide by 8 by 2, and I get c equals 4. I now have to do the other part and go backwards. 4 plus what is 12? And once again, you still get your Vans is 8. So either way, we're going to have the same answers with substitution or elimination. In this case, which was your easier method in your opinion? Elimination? It won't always, Kylie, but it was in this case. I want to show both because you may go down one road, I may go down a different road, and we need to be comfortable doing it either way. Are we clear there? So, first scenario. If you have two variables, how many equations must you have? 2. All right, second situation. I love this problem. It brings back some geometry. Let's think geometry. I need to figure out equations to end up having it solve for x, for y, and for z. Can you think of any equation relating to this? Let's look. We have a star. In the middle of the star is a pentagon. The star is made up of 5 triangles surrounding the pentagon. Can you think of any formulas relating these variables with the ideas of geometry, pentagons, or triangles? Marissa, give me one.
Y plus c equals 180.
Okay, so you are using the idea of supplementary angles. Do you guys remember what the opposite of supplementary is? The 90 degree? Sean? Complementary. Okay, so there's our first equation. Can you think of another equation using those ideas? Paul?
X plus 2y equals 180.
X plus 2y equals 180. So you're using the sum of the angles of a triangle equal 180. Now, little bonus information here. Does anyone remember this formula? N minus 2 times 180. That has to do with the measure of all of the angles added up in a polygon. And n represented the number of sides. And so I kind of actually worked this out for you here. And I said, hey, reminder, the sum of the angles in a pentagon is 540. Well, let's do some labeling here. I'm going to label all my pentagon corners with z's. So how many z's do we have? All told, we have 5. And that equals 540. Now, if this hadn't been a pentagon and it was just any quadrilateral, you could have, Tom, taken the number of sides, plugged it in. And the reason this is 540 is because it's 5 minus 2 is 3 times the 180. That's where that 540 came from. All right, so talk to me here. I have 3 equations. I have 3 variables. Give me any suggestions as to how to attack it now. What do you think? Go, Paul.
Get z by dividing 540 by 5.
Okay, so we're going to get z by dividing 540 by 5. All right, so let's divide that. So z equals 108. Okay. What's next? Do you want to solve for x or for y? Take your pick.
Y.
Okay, so let's use the first equation. Y plus z equals 180. So y plus 108 equals 180. So subtract 180 from, or subtract 108 from 180. I get y equals 72. By the way, 72 what? What kind of units of measure? Degrees. All right, now let's solve for, what do we need? X. So I'm going to use the second equation. X plus 2y equals 180. So x plus 2 times 72 equals 180. What's 2 times 72? Can you do it in your head? 144. Thanks, Henry. And let's subtract 180 minus 144. What does x equal? 36. Let's see. So we used the first equation, we used the second equation, we used the third equation. So we should be in good shape. Questions? You're going to use the information that you have to kind of solve from there. Now, let's just kind of look down here. We're going to do a little setup so we're all being consistent here. What three things do we have on number 3? Hot dogs, hamburgers, and drinks. So let's pick some variables. What do you want for hot dogs? H. What do you want for hamburgers? What? B. And what do you want for drinks? D. Okay? So there's going to be your variables there. I'm going to highlight your first situation. Whoops, that wasn't highlighting. I don't know why my pen's not working here, sorry. So here's our first situation. You buy 1, 2, and 3 for $14.50. Your second situation says one of each item costs $7.50. What that means, Greg, is I go up to the stand and I said, hey, I'll have a hamburger, a hot dog, and a drink. That doesn't mean each one costs $7.50. And then the third situation, I guess I can underline here, 2 hamburgers and 2 drinks cost $10.50. So are you going to be able to create 3 equations there with H, B, and D? All right, so let's go down to this next one. Tickets to a show cost $3 for students and $7 for adults. You sell 250 tickets and it costs $1,102. How many variables are we going to use on this one? I don't think 3. Why 3? There's only two pieces of information. What are the pieces of information? How many of each ticket? What kinds of tickets do we have? Student tickets and adult tickets. Now, Joey, I want to stay away from S for student. Stay away from S. Don't ever use S. So, Joey, pick a variable for students. R, okay? And pick your variable for adults. P. Can I go with A for adult? I mean, when you want to, you can pick those up. So there's some variables there. Okay, let's look down at the next one. The area of a rectangle and the perimeter of a rectangle. Find the dimensions. Probably what are your variables? L and W for length and width. Okay. And so what we're going to do here is I've got 5 problems on the remaining part of the worksheet here that I want us to go through and set up and solve. All right? And that's pretty much our whole lesson for today, as we are setting up and then solving. And that's our whole goal here, is just to practice how we set up. Does that make sense? All right, let's go to it. We've got the rest of the period to kind of go ahead and do that.